Alright, so here we are in video 3.2a. It's the first video for 3.2. 3.2 talks about linear equations in two variables. So we talked about in section 3.1 the fact that we can kind of take a look at a graphic representation of a line and kind of get some information that's not really readily available in the graph itself or the line itself. So in the graph we can get more information than compared to just a line or just a table. So here's what we're going to do in section 3.2 in A. Again, we're in the rectangular coordinate system. 3.2a talks about all these bullet points, including that bullet point too. We're going to get to that in just a second. That should be a bullet point. But in this video, we're going to talk about defining a linear equation in two variables and then kind of graphing the linear equation by plotting points. So let's go to the next slide and see what goes on now with this stuff. So here's linear equation in two variables. This is the title of our section. And we're going to talk about these 4 bullet points. So here's, in fact, we talked about those 4 bullet points just before. So here's a definition of, I guess, of what we had in chapter 1, a linear equation in one variable. And here's what we have in chapter 2, or sorry, chapter 3, which is what we're talking about today. Linear equation, two variables. Linear equation is really important to talk about. That, in fact, it's a linear equation because the power on the x and the power on the x and the power on the y, when we've got two variables, the power is always 1. That makes it a linear equation. Anytime you have the power, the exponent on the variable as the first power, exponent on the variable, first power, exponent on the variable, first power, then we've got a linear equation. This has one variable over here, just the x. A and b are numbers, 0 is just a number, or sorry, 0 is just 0. And then there's an equal sign. Linear means we've got the variables to 1 power, to the first power. Equation means we've got an equal sign. And then we've got two variables. We've got x's and y's. So essentially that's what the similarities are. The differences are that the solution set for a linear equation in one variable just means that, well, we've got x equals a number, because all this b would go over to this side of the equal sign. Then you divide by the a if it's different than 1, and you put that as a number over here, and then you get x equals some number, and that's where this is. And essentially with this, we would have a number line. There's our 0, and then here's our x value, and that would be our solution. We'd have 1 point on that number line. So it's on a number line. It's on just one number line, a number line, just one. And we go on solution. There's our x value, and we've got a point on a line. So there's our linear equation in one variable as a solution. So if we go over here and we say, well, how about a linear equation in two variables? Now we've got two variables. We got ax plus by equals c. Our solution set is essentially a set of ordered pairs. It's a set of ordered pairs, x comma y. For any x that you put in here, y is going to change a little bit. For any y that you put in here, x is going to change a little bit to make the equation an equal sign, or make the equation balance, I guess. So we've got an infinite number of ordered pairs. It's a set of ordered pairs, and essentially it's going to have to be on two number lines, because over here, with one variable, we've got x equals a number. That's on 1 point on one number line. Over here, we're going to have an x number line. We're going to have a y number line, and we're going to have two number lines. We're going to have an infinite number of solutions instead of one, and we're going to have an entire line instead of just a point on a line, because here in our solution set is just a point on a line right there. All right, so there's the compare and contrast. So just like with linear equations in one variable, we can determine if an ordered pair is a solution to a linear equation. So in other words, if we've got a linear equation here, linear equation means x is to the first power, y is to the first power. We've got a linear first power and an equation, so we've got a linear equation. Is 2 comma 0 a solution to this line up here? Well, we'd have to check to make sure that here's our x value, here's our y value. Remember, we can kind of cheat and kind of give ourselves a little mnemonic device or memory device and how to remember that. Here's our x value, here's our y value. Well, is it a solution? Well, if it is, then we'd have to, number one, start with 4x minus 5y equals 8, and that's our linear equation. And does 2, 0 fit into this equation? In other words, does it make the both sides equal to one another? We have to substitute in for x the value of 2. So we've got 4 times x is 2 minus 5 times y is 0 equals, with a question mark over it, 8. Well, we're not really sure, but right now we're going to check it out. 4 times 2 is 8 minus 5 times 0 is 0 equals, with a question mark, 8. Well, sure enough, it does check out, because 8 is equal to 8. That minus 0 can go away. 8 is equal to 8, so therefore 2, 0 is a possible solution. Is it a solution? Yes. You'd have to answer yes. Well, you know what? 3, 1 is really close to 2, 0. It's, not too far away. It's only 1 away from the x value. It's only 1 away from the y value. We would assume that that should be part of our solution. So let's try it out. Is 4x minus 5y equals 8 satisfied with the point of 3, comma 1? Well, you know what? Let's check our x and y here. X is 3, so 4 times 3, x is 3, minus 5 times y is 1, equals with a question mark 8. Well, I'm not sure, but that's why I put the question mark. 4 times 3 is 12, minus 5 times 1 is 5, equals with a question mark 8. 12 minus 5 is 7, equals with a question mark 8. No way. So no, 3, 1 is not a solution. Not a solution to that line. So therefore, that's how we would check whether a solution, whether a point is a solution for a line. All right, next page. A lot of times, like I said in 3.1, we can get a line like this, and we can say, well, we can get some information about it. We can kind of look at it and say, we've got some information, and we can even look at a table and say, well, we've got some information about it, but you know what? Sometimes it's going to be helpful to graph it over here. And by the way, there is something wrong with this graph. If anybody checks it out, you'll notice that, well, this is scaled 2, 4, 6, 8, 10. That sounds great. And the scale should be the same on this side of the x line as this side of the x line. So it's negative 2, negative 4, negative 6, negative 8, negative 10. Sounds good. These are negative 2, 4, 6, 8, 10. The scale on the y value does not have to necessarily match the scale on the x value, but the scale on the y always has to be consistent. So here's 2, 4, 6, 8, 10. This should be 2, 4, 6, oops, 8. Oops. 10. And by the way, I didn't make this myself. I borrowed it from, stole it from, got it from the internet, so therefore it's not my fault. Anyway, just make that my minor modification. We'll move on. So we're going to try and make a graph out of this information, which is really this information here. We've got a linear equation and two unknowns. Linear means x to the first, y to the first, so it's linear equation. There's an equal sign. And we're going to see what it looks like. So we're going to graph a couple points. There's one way that we can do it is just by plotting points. So we go over here. If we need to plot points, we just make an x, y table, and we say, well, I'll just throw in some numbers here, and we can get some ordered pairs out of this. So if x equals 0, then we go back up here and we find out what y is equal to. Well, if x is equal to 0, we start with x minus 2y equals 8, and we put x equals 0 in. So if x equals 0, then what's y? X minus 2y equals 8. X is 0, so minus 2y equals 8. So if we divide by negative 2, we divide by negative 2, and we get y equals 8 divided by negative 2, negative 4. So that's our value for the y value if x is equal to 0. Alright, so that said, let's go for y is equal to negative 3. If y is equal to negative 3, then we start with our, again, equation, x minus 2y equals 8. Always start with your equation so you know where you're starting from. And then plug in the value of y equals negative 3. All right, well, x we don't know. Minus 2 times y is negative 3, equals 8. We've got to find a value for x, so we can put it over here. X plus 6 equals 8, and we can do subtract 6 on each side to find that x equals 8 minus 6 is 2. So that goes right over here, and we've got 2, negative 3. And let's see, let's do the final one and say, well, let's see, if we've got x equals 4, just to make sure that we have calculated correctly and to get 3 points on our line, we can start with this, x minus 2y equals 8, and if I've got x equals 4, what do we get? 4 minus 2y equals 8. Let's see, subtract 4, and we get negative 2y equals 4. Divide by negative 2, divide by negative 2, and we get y equals negative 2. So we put a negative 2 up here, and we can plot those 2 points. Sorry. We can plot the green and the blue and the red point, and we'll see what we can get. Well, let's see if I can get green here. Whoops. I've got green. I'm going to eraser. Sorry about that. we got green point is 0 in the x direction, and y is -4. So 0 in the x direction, y is -4 right there. There's our first green point. Now we'll go to blue, and we'll say if I got blue, I got 2, -3, 2 in the positive x direction, 1, 2, and then -3, 1, 2, 3. There's our blue point. So 2 points makes a line, right? Well, you know what? Let's just double check and make sure that we've got our points correct. 4, -2, 1, 2, 3, 4, -1, 2. There we go. Looks like those 3 lines are collinear, right? So let's make our line, and we'll make it in black just to make sure. And we'll draw it freehand. Unfortunately, that is not perfect, but you know what? There's our line. Now, just for fun, I'm going to throw another number in here, and I'm going to say, what happens if, and I wish I had left some space here, what happens if we put x is equal to, let's say 8. And I'm going to have to write over that green. I hate to do that, but I'm going to put another point here. And what happens if x is equal to 8? Well, if x is equal to 8, well, I'm going to take some space up over here. I start with x minus 2y equals 8. And I put x equals 8. 8 minus 2y. And you'll see where we're going with this real soon. 8 minus 2y, because x is 8. We're going to find out what the y value is. We'll subtract 8 from each side. Subtract 8 from each side. We get -2y equals 0. Divide by -2y. Sorry, divide by -2. Y equals 0. And there's our point 0. 8, 0. And sure enough, if we graph the black point, 8, 0, 8 in the x direction, 1, 2, 3, 4, 5, 6, 7, 8, and 0 in the y. You know what? Good enough. That sure does. You know, even with my freehand drawing, that made a good drawing because it did cross over at that point too. So there's our next point. But why did we do that? Well, 2 things really come about because of this. Number one, the green point itself is important because that's where the line itself, that linear equation, crosses the y-axis. The black point that I added is important as well because that's where the line crosses the x-axis. And we'll find out in the next video why those are important and what, kind of what we can do with them.